Hello everyone. So I have been working on getting to work the foliage, vegetation and grass on the planet generation system that I have been working on. So here is the preview. Now I have both grass and also foliage system implemented into the planet. So here if I start playing, let me play there. If I go closer to this grassy area, you can see grass spawned on the land. Now we have grass just like in our flat world. And it looks a bit odd right now because we haven't added the atmosphere yet. That's why you see this kind of artificial looking lighting like on the moon surface. But we will be working on that also soon. So yeah, grass and foliage is working now. Dash from the character scale of the planet. It's mountain, sea, beach, snowy peaks over here. So yeah, that's one thing. Now here, if I select the planet, I added a new feature. Let me clear. So here, if I press randomize, you do get this different landscape. So now you can see we have different continents compared to what we had before. So it's all depends on this seed number. So if there is a particular seed number that you like, you don't need to use randomization. Let's say you like 0 configuration and preview. This is how it looks. So no matter as long as you keep the same distance, it is deterministic. You will be having the same landscape in different games, like different playthroughs. Okay, so here are some technical details. So I am using hierarchically instanced static meshes for foliage and instanced static meshes for grass. So for foliage, that means like trees, rocks, bushes, anything like bigger stuff compared to grass. We are reusing the same data assets that we implemented for the the world gen system. So here you see there is foliage and grass. These are the same data assets that we implemented for WorldGen. So you can use the same things here. It just work on this planetary landscape too without any issue. You have all the controls that you had before. For example, here you can control density, range, max, slope range, offset, jitter, scaling, and it supports clustering as well. So yeah, all the settings that you need are here. That's for foliage and for grass. This is the grass clump I'm using. So here also you have all the settings you need to customize your grass. So yeah, you can assign what kind of biome you want to spawn the grass, so your foliage. Here I will show the biome means here you have the beach and the grassy area and then rocky area and then snowy peaks. That's what I meant by biomes. And here you can assign which biome that you want to spawn these different kinds of foliage. And yeah, theoretically, the align to we have this align to normal toggle for both foliage and grass. So in a flat landscape, align to normal would mean aligning to the surface normal of the flat landscape. This is useful for things like grass clumps where you want to avoid any floating grass on the landscape. And this is the same thing, but in the planet we have a sphere instead of a flat terrain. By flat I mean like a horizontal plane terrain. So still it behaves in the same way. In the planet, up means the normal, that is the vector that is starting from the center of the sphere and goes outwards through the position where the grass is spawned. So this is how I have calculated surface normals. Here is the equation if you are interested. I don't want to talk in detail about these things, but if you have any questions, feel free to comment below. And I have two things regarding foliage placement: grid and a jittering on the placement. You can use this. There is a parameter to define how much jitter you want for each instance to break the grid pattern. If you don't have any jittering, you would see like the foliage instances are spawned in a specific grid that looks unnatural. So to prevent that, you can use this parameter. And also we have this clustering algorithm as well. This is used to simulate something like a natural spreading of a tree, like you have one big tree in the center, and around that, as the seed is spread, you get smaller few other trees around that. Something like that is simulated with the clustering algorithm. And as for grass, we are using bilinear interpolation to determine the location of the grass instances that need to spawn. So this data is already available because we calculate them in the generation of the mesh, so we can reuse them. It's better for performance. And this slope sync is something I have implemented to prevent floating grass clumps when there is a slope on the landscape. And the GrassViewDistance is mainly to limit how many grass instances are spawned in the runtime around the player. This is also for performance reasons. The higher the GrassViewDistance, higher the number of grass clumps that you will have to spawn. So you have control over that depending on your game performance requirements. So this is the same as the flat terrain version, flat terrain system too. Sorry, not flat terrain. The terrain has mountains. I mean the horizontal world, not the spherical world. So yeah, this foliage building is happening. It's async. So that means in the thread pool, sample vertex data, check biome weight, all these things are happening asynchronously, and then they are uploaded to the game thread for spawning. And this is that randomize button that I showed you to randomize the landscape totally on the planet. And yeah, the seed, the generation is deterministic, so if you want to have the same landscape, you can keep the seed without changing. Yeah, so that's all with regard to the system that I have worked on. Maybe next time we should work on adding atmosphere to this. So yeah, and thanks for watching. As always, updated project is available for you to download in my Patreon page, and also it will be available in Fab as well once it is ready. And don't forget to like and subscribe. And also here is the previous playlist of the tutorial series that I did on creating a spherical landscape. I'll leave the link to that also in the description if you are interested. But here I am using a different method, but still it will give you some idea if you are interested in building a system yourself. And don't forget to like and subscribe, and see you in the next video. Goodbye.